Alright guys, in this second video, the plan is to do these next 4 questions. First one, sorry, went a little long because my timer wasn't working. And I'm going to save the last couple questions for end because the last question has several parts to it. So I think this breakup kind of makes sense. This division of labor between the videos. Okay, so 28 starting first. I got f of x equals to 3 to the x plus 2. And I want to find f inverse of x. So how do we find inverses? Same strategy as before, just like in the previous chapter. Start by rewriting with x's and y's, and then reverse the x's and y's. And then solve for that y. Okay, so how do I solve for this? Well, I want to pull this y down, and the most natural way to do that to me is to just take logs, right? Logs is going to undo it. Now here, I'm not concerned, I could take really any log I wanted, but I'm not concerned about entering this into my calculator here. So I'm going to take the log base that matches this base over here. I'm going to take log base 3. On the left side, it's going to just stay log base 3 of x, right? The right side, this log is going to undo this exponent. So those guys are gone, and it's going to bring that exponent down to earth, so it's y plus 2. Now just subtract 2 on both sides. I got y is equal to log base 3 of x minus 2, and there's your function. Now I'm going to do something that trips people out a little bit, disturbs people, but I'm just going to reverse the order of those because I like it on the left. This is not really a necessary step, but I like it that way. It just feels more comfortable. And instead of y, I'm going to replace y with f inverse of x, because that's what it is, right? The inverse function is that thing right there. And voila, we found what we needed to find. Now, if you wanted to take a step further, you could set the domains and ranges. And the way to do that is start with your original function. Look at what is its domain and range. And just make sure that it's the opposite for the inverse function. In this case, it's really the... let's do that. Let's do that, actually. So 3 to the x plus 2. Think with me through the graph for a second. Goes here, and then it doesn't quite hit 0, right? So okay, so this is just kind of a bonus piece of this. The domain for that original function, domain is everything, but the range, like we just saw in the picture, it never hits 0, but it goes up forever, right? What about the inverse function? Oh, you know, actually, guys, I'm sorry. I forgot about this translation. So that range is actually not totally accurate. Is that not accurate? Let me think for a second. So the domain can be anything, yes. The range, x plus 2 is a translation by 2 to the left. So 3 to the 0 would be 0, 1 normally here, but that's going to be here now. Okay, actually, yeah. So that's actually the same. Never mind. Your range is still 0 to infinity. Okay, what about the inverse function? So inverse function, let's take a look. Okay, this time the domain is anything that makes sense, right? So here, the thing that doesn't the thing that makes it not make sense is if that inside is negative. So the domain is from 0 to infinity. You see that? And what about the range? Well, log function, okay, this one is got shifted 2 down, but the log function, it looks something like this, right, in general? Normally it passes through that point. 1, 0, it goes like this, right? But this one is shifted 2 to the 2 down, so it's going to go through this point instead, go like this. But still, it's going to go up forever. So eventually, you're going to catch up to where you would have gotten. and you get negative infinity to positive infinity. And so note that these are swapped, right? So everything makes sense in the world. That wasn't asked of us, but that's kind of just the double check. If you have a proper inverse, the domain and range should be the reverse of the original function. And indeed it is the case for this. All right, that was 28. Took the long-winded way for that. Let's do 29. This time I'm not gonna bother with the explanation of domains and ranges because we just seen it. We kind of understand it, I think, right? We've seen it a bunch of times actually. Okay, so original function is log base 3 of x minus 1. Oh, you know what, guys? This question really should have the parentheses. Or no, actually, we shouldn't assume that, yeah? We shouldn't assume that. So it doesn't show parentheses, so we'll just take it at face value and see that that's log base 3 of x and then subtract 1. Okay? Either way, you could find the inverse, but we'll take that as the one. Okay, so okay, how do you solve this thing? Remember, first step, change to x's and y's, and then reverse the x's and y's. And I'm going to solve for y. Okay, first step is to add 1 to both sides. So I get x plus 1 is equal to log base 3 of y. And then to get rid of this log, I don't like the log there. I want to get y by itself. We're going to do the inverse, which is hit it with the exponent, right? On the left side, I'm going to get 3 to the x plus 1. On the right side, I'm going to get this 3 under the log, so I just get y. And right there, I'm done already. I'm going to do the same thing and reverse it. So f inverse of x equals 3 to the x plus 1. Okay, so there it is. Okay, and that's, looking at the function, that's, I took the inverse of what is written there, exactly as it's written, because as it's written, that's log base 3 of x, and then subtracted by 1 afterwards. To be more clear, it would have been nice if there was parentheses where it belongs, or if you actually meant x minus 1, it would have been nice to have parentheses there. So just in case you misread the question, I would feel bad about marking you wrong, so I would also allow you to have solved this question. I wouldn't have marked it down because there's a little ambiguity there in the way it appears, I think. So let me just show you that one real quick too. Right, I'll do the same steps. Replace with x's and y's. Swap the x's and y's. And then this time, hit it right away with the exponent. I get 3 to the x equals to these guys under each other, y minus 1. So then, adding one to both sides, I get y is equal to 3 to the x plus 1. And then that would mean the inverse function would be 3 to the x plus 1. So the only difference is where that plus 1 ends up, right? If it's part of the exponent or on the outside. That was 29. We did 28, we did 29. Let's move on to 30. All right, 30 is an easy question. It says just to rewrite the log base 15 in terms of ln. That's just a change of base formula, straight application. And remember, when we do the change of base, we're free to choose whichever base we want, but ln is a natural choice. They even told us to choose ln this time. And then when you do the change of base, remember, top number goes up top, bottom number goes down bottom. So it's going to be ln of the top number divided by ln of the bottom number. And just like that, that's it. You're done already. Yeah? Log base 3 of 15 is equal to what I just wrote. Now to give the decimal approximation, ln 15 divided by ln 3. Check this out though, guys. Wait, let me clear this. I could use either ln or I could use log, and I get the same result either way. So if you don't like ln's and you want to check your answer, you could use just a regular log just as well. Why is that true? Well, it's true because the change of base gave us freedom for which one we choose, right? But the only thing is, I will say, make sure you're consistent. If I'm going to use ln one time, I gotta use ln the other time. I've done this before, but just to prove to you that it's true, watch. Do log 15. Oops. Not like that, not within the log. Two separate logs. Divided by log of 3. And boom, see, same thing. 2.4649, but it's a 97 to the nearest 4 would be 2.4650. 2.4650. 2.4650 to the nearest 4 decimal places. And that's 30. That's easy. Okay, 31, half-life question. Okay, we're using this formula for these half-life questions, or these decay or growth questions, right? Half-life of a certain radioactive substance is 30 hours. That would be a T. That's a big T. Half-life. What is the rate of decay? Okay, so with just this first sentence, we can answer that first question. So A is equal to P e to the RT. We're trying to find R. E is already a number. T is given to us as 30. So we got e to the R times 30. What about P and A? Well, P is the starting position of 100% or just 1. And A is the ending of 1/2. Okay, so 1/2 of where you started with 1 whole is equal to 1 times e to the R times 30. I'm sorry, 1 times e to the... Oh, yeah, I said it right. R times 30. Okay, so I want to solve for R. How do I solve for R? I want to pull down that exponent. I want to do the inverse, right? So ln both sides. And this one, I don't have to worry about that because it's just 1, right? 1 is just, it's nothing. It's just the identity. So I've got ln of 1/2. And ln undoes the e, so I get R times 30, or let's write it like 30R. Yeah. Divide by 30 on both sides. R is ln of 1/2 over 30. ln of 1/2 over 30. Let's punch that in. ln of 0.5 divided by 30. And it's negative 0.0231. Negative 0.0231. Negative 0.0231, roughly. That's the first question, yeah? What's the rate of decay? About negative 0.0231. How long does it take for the substance to fall to 20% of its original value? All right, so we're going to come back to our original A is equal to P e to the RT. And we're going to fill in the parts that we know. The only thing that we don't know is the time that we're trying to figure out, right? So A, 20%, you could write that as 20. And P is 100. Or if you prefer, you could write it as 0.2. And P is 1. E to the negative 0.0231 times T. And T is the thing we're trying to figure out. Okay, hit both sides with the natural log. Yeah, natural log of 0.2. Natural log of this thing. What does the natural log do on the left? Just becomes a natural log of 0.2 like it says. On the right, forget about the 1. I got natural log of e to something, which means undoes it. And I got negative 0.0231 times t. Remember, I'm trying to solve for t, right? So divide both sides by that negative 0.0231. And t is natural log of 0.2 divided by negative 0.0231. Now, technically, this is an approximation as soon as I introduce this guy right here. But I'm going to kind of just, I'll just say at the end that this is an approximation for t. So ln of 2.2 divided by that thing. But, I have it in my calculator already. So the best way to go about this is to do ln of 0.2 and then divide by the answer. In my calculator, if you type in A and S, it inputs the answer. Most calculators have a button for that. Let me just double check I put that correct. ln of 0.2 divided by the R. Yeah, okay. Okay, so looking at it, that's 69.65. Let's just round to the nearest year since it didn't ask us specifically what around. That'll be about 70 years. Oh, I'm sorry, hours, not years. This was hours. It's about 70 hours. Okay, there it is, guys. So yeah, see you in the next one.